Today we'll be discussing the composition of functions. So you're going to look at putting two functions together for their composition, and then also decomposing a function as two different functions. So when we say we want to compose a function or find the composition of f and g, which is written f little circle g, all that means is I'm going to take g of x and I'm going to plug it into f of x. So everywhere I see an x in f of x, I'm going to plug in the entire function of g of x. We have to assume that x is in the domain of g and that g of x is in the domain of f. So basically, whatever this simplifies to, you need to look at its domain, and you also want to intersect that with the domain of g itself. So let's see some examples. It'll actually make a lot more sense there. Let's suppose f of x is 2x minus 5, and g of x is x squared minus 3x plus 8. Then we're going to look at f of g of x and g of f of x. I could have also said that f composed with g of x and g composed with f of x. So all we're going to do, and all I want you to picture in your head, is taking that circle and drawing a parenthesis instead. Because then you know it needs to go f of g of x. So then I'm going to take g of x, I'm going to plug it in for x inside of f of x. So this equals, let me write down the framework for f. I give myself some room where the x is, minus 5. There I've written down f, and we can plug in what g of x is in place of where the x goes. So that is x squared minus 3x plus 8. So I've taken g of x and I've plugged it in for the x inside of f of x. That's what it means to compose f and g. I've just plugged g into f. So now we simplify, and I get 2x squared minus 6x plus 16, distributing my 2, minus 5. And in the last step, I'll combine the 16 and the minus 5, and I get 2x squared minus 6x plus 11. So that is what f composed g of x equals 2x squared minus 6x plus 11. Now, alternatively, I could have plugged f into g, and you'll see we get a very different answer. So if I've plugged f into g, think, okay, I'm going to draw a parenthesis over my circle, which means I'm looking at g of f of x. Okay, so I got to take this f of x and plug it into g. So that is, g is my outer function. I'm plugging in 2x minus 5 into everywhere I see an x. So I'm looking at 2x minus 5 squared for the first term, minus 3 times 2x minus 5 plus 8. So now I've plugged in 2x minus 5 everywhere I see an x inside of g. That's the order it asks us to go in this time. So now we got to simplify this. And for this first term, we got to FOIL it. I like doing these kind of as little aside jobs. And I'll write it right at the top here. So just kind of as an extra work, kind of little aside thing, we're looking at 2x minus 5 times 2x minus 5. I know I couldn't do this in my head, so I suggest you write it out as well. We're looking at 2x times 2x first, which is 4x squared. Next in foiling is the outer, so 2x times minus 5, minus 10x. And then we have inner, minus another 10x. And then last, which is a plus 25. So here we have 4x squared minus 20x plus 25. Okay, so all of that goes in for our first term here, 4x squared minus 20x plus 25. Minus. So there's the first term simplified. Now we got to distribute the minus 3. So I have a minus 6x plus 15. Notice the minus 3 times the minus 5 makes a plus 15. And I've still got the plus 8 at the end. Now we just need to combine like terms. So I have a 4x squared, and I have a minus 20x and a minus 6x. So that's minus 26x. Now I have a plus 25, plus 15, plus 8. So that is plus 48. 25 and 15 makes 40, plus 8 is 48. So G composed f of x equals 4x squared minus 26x plus 48. So notice how these two are very different. As soon as you plug one function into another one, you might be looking at very different answers depending on which one you're plugging into which. Okay, so you have to just pay attention to the order. And that's why I like to think, okay, just replace the circle with a parenthesis, and that gives you the order. It's G, either f of g of x or g of f of x. So let's look at another example. Let's suppose we have f of x is x minus 5, g of x is x plus 8. We want to find f of g of x, f of x, so plugging into itself that time. Now we're going to look at f of g of 2, so what happens when we're plugging in a number, and then find the domain. So, starting with f of g of x, remember, we just do that to think about order. So it's f of g of x. So we know we're plugging in g of x for everywhere we see an x in f of x. Okay, so f of x is kind of this outer function. So it's something minus 5. And that something that I'm plugging in for x is all of x plus 8. So x plus 8 goes in place of my x for f of x. And then I do the minus 5 for the rest of f of x. All right, notice I've just plugged in g of x in place of the x in f of x. Now we just combine like terms, which is simply x, and I have a plus 8 and a minus 5 is a plus 3. So we could write down f composed g of x equals x plus 3. Now we're going to talk about, well, what happens if I'm looking at f composed f of x? Well, that's just f of x. Okay, so I'm plugging in f of x inside itself. Interesting. So let's look at that. Here, I know I'm plugging in x minus 5 into itself, which means I write down, sometimes I like to leave myself a blank. Maybe that's a good way to think about this. So if I'm writing down my outer function f, I'm going to think, okay, let me leave a blank where x is and fill out the rest. So I can leave a blank where x is minus 5. And in that blank, you can insert whatever this inner function is. So we're leaving that blank anywhere we see an x, and now we're going to plug in what we need to plug in, which is f of x. So x minus 5 goes in the blank. Right, so we've plugged f into itself. You leave the blank where x is, you do the minus 5, and then wherever x is, we plug in whatever function we're told to, and in this case, that was f of x. So now we have x minus 5, which is x minus 10. So that was part B. Now what happens when we're looking at f of g of a number? Well, luckily it's what we're used to doing. So if I want to think about f composed g of 2, I'm looking at f of g of 2, which is really just plugging into the function we got before. So 2 plus 3, which is just 5. So you see I'm given an x here, so I plug in 2 for my x value, and I get 5. And that's as simple as that. Just figure out what the composition is and plug in the number you're given. So this was part C. I'll go ahead and label these. Part D now, we're going to think about the domain of f of g of x. Whenever you have to think about the domain of a composition of functions, I want you to think about two things. So first, you have to think about the domain of the simplified f of g of x. All right, so we have to look at, okay, what is the domain of our actual result? So in this case, that would be our x plus 3. You also then need to think about the domain of the inner function, whatever's on the inside of the parentheses of that outer function. You got to think about the domain of that. Because if I can't plug into that inner function, then I can't take a does not exist in here and plug it in for my f function. So it's important to think about, okay, what is the domain of my actual result and what is the domain of that inner function that I plugged in? And then you take the intersection of those two domains, so wherever they overlap. For this example, it's a little bit simpler because both these domains for f and for g are just negative infinity to positive infinity. There's no square root, there's no fraction to be worried about. So we just know the domain in this case is quite simple. Negative infinity to positive infinity. I can plug in anything into this function or my actual result. So we're good to go. There's not too much to overthink here. But you'll see a better example in that in the next slide. So now we do have a square root. So we're going to look at f composed with g, g composed with f, and then think about the domains of each. So first off, f composed with g of x. Well, that's simply f of g of x. So I need to take my f, I need to plug in g. Well, f is my square root function, and where I see an x here, I plug in where I see my g. So x minus 3. I've plugged in g of x for x. Now, let's jump to the domain of this guy. So I need to first think about what is the domain of the square root of x minus 3. And then second, I need to think about the domain of my g of x, because that's what was plugged in. Okay, that's my inner function. So what's the domain of g of x, which is x minus 3? And then we have to take their intersection. Okay, so what's the domain of that overall function? So that first part, well, it's a square root function, right? So we need to make sure that what's on the inside, x minus 3, is greater than or equal to 0. Well, in this case, if I add 3 to both sides, I know x must be greater than or equal to 3, which means I'm looking at the interval from 3 to positive infinity. Right, any values above 3 make my square root positive, and so therefore that's my domain. Those are all my valid possible values of x to plug in. Now I'm looking at g of x equals x minus 3. Well, the domain here is, again, it's linear. There's no special things going on here. There's no square root. There's no fraction. So the domain of g of x is just negative infinity to infinity. So we take these two, and we now know by looking at their overlap or their intersection that the domain, I better give myself some space. The domain of f composed g is 3 to infinity. It just ends up being that first part. So now let's look at g composed with f. So if I have g composed f of x, now I'm looking at g of f of x. Okay, so I got to plug in f inside of g. Well, g is this x minus 3, so I'm going to do that kind of blank minus 3 idea. Now I got to plug in my function, f of x, anywhere I see an x, which is where my blank is, and f is the square root function. So this becomes square root of x minus 3. So here the minus 3 is not inside the parentheses, or inside the square root function. Okay. So that's it though. That is my composition here. Square root of x minus 3. So for domain, we need to think about, well, what is the domain of root x minus 3? And then what is the domain of my inner function f of x, which is just root x? All right. Now, luckily, these actually have the same domain. Because the only thing we have to worry about is when our x under the square root is positive. We need x greater than or equal to 0. Or essentially 0 to infinity. And that's the same about either that first part, root x minus 3, or just root x. We always need x to be positive there. So we need to look at values from 0 to infinity. And that's it. That's the domain of Decompose f. Moving on to this one. So we have a couple more fractions going on here, and you're really going to have to focus in on the domains of these questions. So looking at f compose g first, that's f of g of x. So I need to look at my f of x, and I'm plugging in g of x everywhere I see an x. Okay, so f is my outer function. That's that 7 over 1 minus. Now instead of x, I write g of x, 1 over x. However, we actually need to simplify this because we can't have a fraction instead of a fraction and call it the simplest form. So what we're going to do is I really want to get rid of that over x down in the denominator there, the 1 over x. So I'm going to show you a good trick where we actually multiply the top and the bottom of this fraction by x. Now I can do that because x divided by x is just 1. I'm not changing the problem at all. But so this equivalent function will not have a fractional x, though, in the denominator. So what happens is I get 7x on the top. Now I need to distribute my x on the bottom to both terms. So that's x for 1 times x minus, and then really this would be x over x, just to really show you kind of what that distribution looks like. But in reality, this is now 7x over x minus 1. So now that is what we call the simplified form. So now if we want to think about the domain, which honestly I like doing it in this order. I like thinking about f composed g and then think about its domain, and then move on to g composed f and think about its domain, regardless of how the problem asks you to answer it. I prefer to just write them down in this order. Your homework asks for it in this order as well, so I suggest kind of sticking with this scheme of looking at f composed g and then its domain, g composed f and then its domain. So all right, we got to think about 2 things, remember. The first one is our actual simplified one. What is in the domain of 7x over x minus 1? And then second, we got to think about what's in the domain of our inner function g. So what's in the domain of 1 over x? Okay. So here we are going to have 2 separate domains, and one of them is not going, neither one of them is just negative infinity to positive infinity. So you're going to see how these 2 have to really come together here. But if I don't have something in my domain of g here, then I can't take that and plug it into f. So you always have to think about this inner function case as well. All right, so here I need to make sure that x minus 1 does not equal 0, which if I add 1 to both sides, I need to look at x cannot equal 1, right? Because that's what cannot be in my domain. So that is negative infinity to 1, union 1 to infinity. Basically skipping over 1 in that domain. Now, 1 over x, very similar idea. X cannot equal 0. Can't have a 0 denominator. So that's negative infinity to 0, whoops, union 0 to infinity. So now I have 2 domains here, and I need to basically take their intersection. I need to see where they overlap. The first one skips over 1. The second one skips over 0. So our domain overall basically needs to skip over 0 and then skip over 1 in the interval for the notation. So that is the domain of our actual answer. So maybe I'll write that. F composed G is negative infinity to 0, union 0 to 1, union 1 to infinity. So skip over 0, go again from 0 to 1, skip over 1, go again till infinity. And that's our domain. That's how we combine these two and how we get our final result. Now, I believe I have another slide, hopefully, for G composed F. Yes. Now we're going to focus on G composed F. So G of F of X is, well, G is our 1 over X function. And where we see X here, we're going to plug in F of X. So that's 1 over, now instead of X, I write F of X, 7 over 1 minus X. Okay, so now we got to simplify this. Again, we have a fraction inside of a fraction. So instead of dividing by a fraction, we multiply by the reciprocal. So I have 1 times 1 minus X over 7. So I flip that bottom one, which of course is just 1 minus X over 7. All right. Now we need to think about the domain. So first we need to think about the domain of 1 minus X over 7. And then second, we need to think about the domain of our inner function F. So 7 over 1 minus X. All right. So for this first one, it's really tempting to say, oh, that's a fractional function. I need to worry about a 0 denominator. But there's no x's in my denominator here. It's just 7. So this is actually considered a linear function because I could write this 1 over 7 minus 1 over 7x. So there you can kind of see that it's really just a linear function. There's no exponent on the x. There's no denominator really to worry about other than constants. So this has a domain of negative infinity to infinity. This one, the second one, is a true fractional function. We need to make sure that 1 minus x does not equal 0. Okay, so if I add, or let's subtract 1 from both sides, I have negative x cannot equal negative 1. And then I divide both sides by negative 1, I get x cannot equal 1. So that's negative infinity to 1, union 1 to infinity. Oops. So that is our domain of the second part. Again, the first part is our simplified version of our composition. Second part is to look at just the inside function, which is f of x in this case. So now we got to combine these two intervals and look at their intersection. First one is all real numbers. Second one skips over 1. So we have the domain overall is negative infinity to 1, union 1 to infinity. Right? Let's do a few other examples. So now let's say we have two constant functions. F of x is just 2.4 and g of x is 0.3. Let's talk about f composed g, g composed f, and their domains. So for f composed g of x, which is just f of g of x, we're looking at plugging in 0.3 everywhere we see an x in f of x. But there is no x in f of x, so we're just going to write down what f of x is, 2.4. There's no x to plug in the 0.3. The 0.3 plays basically no role here. So f of g of x is just the constant function 2.4. And as weird as it feels, when we talk about the domain of this function, we actually have no x values to worry about here. So essentially the domain becomes all real numbers. Now let's think about this properly though, because we have a two-parter every time we think about domain of composition. We have to think about the overall function 2.4, and then we also have to think about that inner function g of x, which is negative 0.3. Both of these are constant functions. They're just numbers. So both of them have domain negative infinity to positive infinity, which means our domain overall is negative infinity to positive infinity. So constant functions always have domain negative infinity to positive infinity. That's what happens when you compose them as well. Now let's look at, well, what happens in the alternate case, g composed f of x. That's g of f of x. So this time we're plugging in f everywhere we see an x over here, but there are no x's in g. So this is just g of x. There's nowhere the 2.4 can be plugged in, so we just take the rest of g, which is negative 0.3. And for the same reason as before, it has domain negative infinity to positive infinity. So that's it. You have a constant function example in your homework, so I wanted to show you what happens when you try to compose constants. And essentially, the function you're trying to plug in just plays no role. So for this second example, 2.4, we had nowhere to plug it in g of x. So g of f of x is just negative 0.3. So now let's talk about going the other direction, because we like to be able to go back and forth. And in calculus, we often need to be able to recognize this, the ability to express a single function as the composition of two others. It plays a big role there for something called chain rule. If you take calculus, you'll end up seeing that, but you need to, at least for this course, get good at decomposing these functions. So essentially, if you're given an h of x, can you find an f and a g where h is this composition? Let's see an example. So let's suppose h of x is 2x minus 3 raised to the fifth. Find f of x and g of x so that h is the composition of f and g. Whenever you do these, I want you to look at wherever you have parentheses or a square root or anything, you're going to draw a box in place of those parentheses or square roots, things like that. That function that you just boxed in is going to be your inner function g of x, okay? So remember, this is f of g of x, like this. And whatever you just boxed in becomes g of x. So g of x is this 2x minus 3. Now this function that you just plugged g of x into is whatever is on the outside of your box. So we still have a to the fifth on the outside of our box. And that is what's playing a role of f. So f of x is the function where we raise something to the fifth. And how do we represent that? Well, it's x to the fifth. You can always check your work. Well, what if I now try to write down f of g of x? And I'm looking at plugging in 2x minus 3 in place of x. So that becomes 2x minus 3 to the fifth, which is indeed what we were looking for. So these are correct f's and g's. Now there can be multiple out. You can actually split up a function into as many operations that exist in that function. But just try to go with the most glaring, box in your inner function. Think about what that outer function is. Go from there. So for another example, looking here, here's our h of x. Find f of x and g of x. The h is the composition. Or look at those big old parentheses, and we just draw a box right in place of them. That inner function becomes my g of x. So g of x is all of x plus 4 divided by 3x squared plus 2. So my f of x is whatever's left. Well, I have it to the 8 on the outside of my box. So that's x to the 8. And if I check f of g of x, so this is just a check step, that is, well, I take all of my f of x, and I gotta plug it in where I see my x. So that's x plus 4 over 3x squared plus 2, all raised to the 8. And so yes, that is exactly what we started with. These are the correct f's and g's to decompose with h. So that's everything for today, guys. Please reach out and email me if you have any questions, and give this a try on your homework.